Hello everyone and welcome to this week's video. We're still going over the back to basics, kind of some of the most common security vulnerabilities that beginners find, and what you can find as a beginner and what people's first bugs tend to be. Today we're going to be talking about cross-site scripting. I have found one cross-site scripting bug. I actually don't recommend these to beginners, but a lot of people disagree with me on that, so I'm going to still talk about them. Personally, I don't think that cross-site scripting is the best vulnerability to go for as a beginner, simply because what you tend to see is on Twitter, you'll see a bunch of bug bounty tips, and then actually when you dig into them, they're just random payloads that will work in a single situation and are not very explainable outside of that. They don't work outside of really specific targets or really specific technology stacks. But cross-site scripting is still really, really common. It's one of the most common security vulnerabilities, so we're going to talk about it. Once again, this entire series would not be possible unless we could get support from sponsors, and our sponsor for the whole series is Bugcrowd. Bugcrowd is the best place to start hacking, with a wide range of public and private programs from APIs to desktop applications and everything in between. Not yet ready to jump into a public program? Fill out your platform CV and sign up for a waitlisted program. Tell Bugcrowd a bit about your skills, previous certifications or experience, and they'll match you up with the right program using their industry-leading crowd match technology. Whatever your level, there is a place for you in the crowd. So, we've talked a bit about how websites are built in this series, and the problem with quite a lot of doing everything server-side is that the only time code can run, the only time a website can do anything, is when a page and when they have a request and a response. So the page has to be reloaded. But you will probably use the internet recently and you don't need to reload the page to click on a button. So JavaScript is a client-side programming language. It's done all on your computer that renders out this client-side language which can help do this. So essentially it allows you to run client-side code on your computer. Now, because JavaScript is client-side, not server-side, you can actually also read JavaScript and you can see how it's being used. So in terms of the history of JavaScript, back in the 1990s, and actually this is true for quite a lot of security issues, as the web had a lot of limitations. The modern internet is very much based off of technology in the 80s and 90s, and that's actually why we see a lot of security issues, because it's based on these older technology stacks. So at the time, Netscape, which was the biggest browser, they wanted to have interactivity. So they approached some microsystems, so they make Java, and asked them to help them embed Java into a website. They realized very quickly that Java was a terrible idea, and that's why we actually call it JavaScript, because it was made by the people who made Java. Now, when Netscape made this, Microsoft saw and were like, we want that too. So they reverse engineered Netscape Navigator, so that's the web browser, and added support for JavaScript to early Internet Explorer. So Netscape submitted JavaScript to standards organizations. However, it kind of didn't really matter. Internet Explorer got more and more popular. And with that, Microsoft wanted to get Outlook, so that's their email client, to work on the internet. The problem is that single activity with JavaScript was only so much. You could still only make a single request each page load. Like, you couldn't also send more requests. So Microsoft ended up inventing XML HTTP request. So essentially what this technology allowed you to do is make the browser make requests in the background using client-side code. So now you weren't limited to a single request to do stuff. You could have JavaScript, click a button, JavaScript sends a request on your behalf. Now you can kind of do something with that response and make really interactive. You think about any really interactive applications, think about email like Gmail, it requires Ajax to exist because your browser and through Ajax is making tons of API requests. If you ever hack, I really do actually recommend hacking some kind of email provider. You will see it do a request for suggesting what emails to put in. They'll have a request. If you attach a file, they'll have a request for actually sending an email and viewing an email, and all that is because of Ajax. It's still only a single page request. So that is the kind of standard. Now, this is kind of out of scope for this video, but essentially when a web page is actually rendered, you are just getting the response, right? If you go into Burp and you see request response, your browser gets the response. So the actual thing that creates the nice little pictures is the browser engine. And for different web browsers, these are different engines. That rendering engine puts stuff on the page. And then after the page is done, then we have JavaScript. So JavaScript will then run all of the code. And this is actually, continually running. So what cross-site scripting is it's not a flaw in how your web browser reads or outputs JavaScript. It's a flaw in essentially running untrusted code. Now, JavaScript is kind of intended to run arbitrary code like it's supposed to, but cross-site scripting kind of allows us to increase the impact of running this arbitrary code, especially on behalf of and pretending to be a website. So there are a few different types of XSS. The simplest one is what's called a stored XSS. So a stored XSS is kind of your bog standard. The XSS payload is sent to the database and is called every single time the page is loaded. So essentially, you can put in arbitrary JavaScript, it gets saved to the database, and then whenever you load up that comment or that post or that video, the XSS payload that's in the title or the description or wherever it is will then appear on the page. This is the most impactful of the XSS types because it's really difficult to argue that the impact is lower. The impact is obviously higher, it gets stored in the database. Now, it's not necessarily a problem if your XSS payload gets stored in the database. The problem comes when the page is then rendering that as JavaScript. So you can see this here. So the best way to test for this is to place an XSS payload in any field on some form. So in this case, this is a comment form. So you place an XSS payload in last name, first name, email, additional comments. Then when you submit it, if you refresh the page, you can see your comments. That is a stored XSS. So the very simple stored XSS payload is script alert 0 script. You shouldn't really stop there though. Demonstrating more impact is how you can start to especially develop more as a hacker. You don't always need to demonstrate more impact, but if you do, you can really demonstrate things like account takeovers, right? That's how a lot of people move on from lower medium bugs into highs and crits. They're looking for that additional impact. The next option we have is blind XSS. So blind XSS is a type of stored XSS, but you don't see the output of alert 0. You don't see that pop up because it pops up on a page you can't see, like an admin panel. So you can use XSS Hunter or crafted payloads to see if the XSS ever fires, but essentially you can imagine, if we take the comment example, if a comment had to be approved by an admin, the XSS payload may appear on their admin payload, their admin control panel, right? It's also really common in reporting posts, in reviews, in, you got to think, where does this go into a administrator control panel? Where would that go? What would it look like? And then we have another example of a report field. So you're looking for places where an admin would look at it, but you wouldn't necessarily be able to see. That is a blind XSS. It is still fundamentally a stored XSS. Like, at the end of the day, it is just a stored XSS. It's just a different type. And these require time, but in my experience, I've seen that blind XSS tends to be one of the most common types of XSS that gets paid out quite a lot, because it tends to be what developers haven't fixed yet. They don't really consider the impact of it. So if you are hunting for blind XSS, you've got two options. So there's a piece of software called XSS Hunter. It was shut down a few months ago, but there's now XSS Hunter Express, which is like a self-hosted version. You can see the instructions are really clear, super easy. You can get set up really quickly. Or you can use Truffle Security's XSS Hunter, which claims to be a kind of more privacy-focused XSS Hunter, though there was some controversy with them storing data. So if you are worried about that, just do XSS Hunter Express. Now, the one downside is for a lot of blind cross-site scripting, you need really short domain names. So these can get very expensive very quickly. So it's worth having a look and seeing whether or not this ends up being worth it for you. Now, the next type of XSS, and the one that I found, is a DOM-based XSS. So they're a little bit more tricky. So in a page vulnerable to DOM-based XSS, something is happening that's using the DOM of the page. So for example, maybe it's using something like document location to populate the navigation bar and add whether or not that's the selected link. So as long as you can edit document location, you can interfere with the nav bar. But really this counts for any page which is using JavaScript to do something on the page. Maybe that's populating a navigation bar. Maybe that's populating a form with existing data that you sent before. That was the bug that I found. That would be a DOM-based XSS. So if the web page prints from a vulnerable JavaScript source, so it needs to have some kind of JavaScript that's editing the page after it's loaded. So maybe that's getting the window location search, maybe that's grabbing the parameters. This takes reading the code. It's well worth it though. I promise it's well worth learning JavaScript. There's a book called JavaScript for Hackers that, if you're familiar with JavaScript, well worth reading. If you're not, I'd probably give it a skip or do a tutorial first and then read the book once you kind of get your confidence. Really worth doing it though. So then you place your payload into that vulnerable location. So you can see on this example here that it's grabbing the parameters. So we just have to set, and you see it's printing out the parameters. We just need to set the parameter to be script alert 0. There are so many potential sources for DOM-based XSS. It is such a broad vulnerability category. I really recommend Portswigger Web Security Academy, just in general, because I think it's really great if you like to learn in more of a classroom environment. That gives you kind of like structured labs, and then it builds on them, and you can look at their information pages. Plus, as you do it, you're actually getting like your burp certification. You still need to pay for the exam, but you're doing all the labs that you would have to do anyway. So I really recommend the Portswigger Web Security Academy. It's all free. There's tons of videos, and actually there's loads of videos by the community as well. So it's not just, there's a bunch of people who think it's worth doing. But I really recommend it because there's so many different ways to cause DOM XSS. I would say, if you were like, Katie, what kind of cross-site scripting should I look for? I would say learn to read JavaScript and DOM XSS, and I'd say blind XSS, especially if it's a newer bug bounty program or it's something that hasn't had a lot of eyes on it yet. Blind XSS is a bit more common then, but being able to read code, being able to read JavaScript, it's such a major advantage. So the final type of actual valid XSS is what's called a reflected XSS. So we've got to compare this to the other ones we looked at. So in stored XSS, our XSS payload is stored by the database. It will appear every single time that comment or that post is loaded up. Reflected is the complete opposite of that. The input isn't stored, it's just reflected onto the page or on another page. So you can imagine a search bar where it's, Google, if you type in a Google search, it will say search results for whatever you searched. that is then where you'd have reflected cross-site scripting. So an attacker would essentially have to send this full malicious link to a victim, and the victim would then need to click on it. This is why reflected XSS has a much lower severity in a lot of situations, because it does take social engineering to actually get someone to click on it. It's much better if you can store something in the database, right? You don't have to convince somebody. So let's have a look at an example. So we might have this form. Maybe it is being stored by the database, maybe it isn't. But the next page says, thank you for your comment, Katie. Thank you for your comment, whoever, right? So if that first name is then reflected onto the page, you can edit that first name to be an XSS payload. And if you can refresh the page and then cause that to appear with your alert 1, that is a reflected XSS. And this is why I think it's kind of important to learn the further impact of cross-site scripting, particularly things like account takeovers. Things like XSS Hunter make this really easy because they will grab things like cookies from the page that you might be able to reuse if the session is still active. But for quite a lot of them, you're going to be looking at CSRF, which is another type of vulnerability that you would have to chain together. Again, especially if you've got a reflected XSS, a lot of people will say, okay, yeah, but what's the impact? Well, the impact is you could steal somebody's cookies, but we don't have cookies in HTTP only. You go, okay, you might be able to cause an account takeover. Okay, how? Again, if you can demonstrate that further impact, that's what bug bounty programs want to see. The final type of XSS is what's often called self-XSS, and this is usually considered out of scope or NA. This usually requires a high amount of social engineering. So it requires you to get them to open the console or edit HTML or include an XSS payload in a form where the results are only visible to them. To be able to get somebody to do that is going to be tricky. Like, it's not even just an email where you can send a malicious link. It's that one step further of saying, okay, do step 1, then step 2, then step 3, and then step 4. And honestly, if you're going to that much effort and they're still following you, you may as well just ask for their password because they're probably going to give it to you, right? Self-XSS is just that other level of, okay, this is going to be really hard to get somebody to do. So it's less hacking, more social engineering. In some cases, if a program does allow social engineering, this might be considered in scope, but I will say very few programs allow social engineering, and even then, it's probably not a huge, amazing finding anyway. So how do you find XSS payloads? You can find or write an XSS payload. There are a bunch of them online. I will say that just copying a big list is not the best way to find cross-site scripting, though I cannot argue with the fact that people have got results this way, and maybe I'm just bad at it. I will freely admit maybe cross-site scripting just isn't my bug and I just don't get it. So you want to find or write an XSS payload. Now, the reason why I say find or write is because often based on context, you need to know how to make changes to that. A lot of the WAF bypasses that you see are because there's a lot of the XSS bypasses are because certain characters are being filtered out, or because in certain context, some things may be passing differently or being saved differently. I'm going to put this in the comments, but there is a really great infographic made by SomeDev where he breaks down what an XSS payload looks and why it's there. Learning that why is so important. And that goes for, I think, all bugs. Simply spamming script alert 1 may work, right? It may work eventually. But if you can understand how to write an XSS payload, why something works, why a specific payload is working, you can get much better results and more impactful results. Saying that, I will say a lot of this testing, at least initially for cross-site scripting, is often script alert 1. Now, depending on how that payload is then passed by the vulnerable form, kind of determines your next play. So, is something being filtered? Is the script alert 1 just appearing on the page? Is the script appearing but not the alert? Is there, I don't know, a filter on the little angled brackets? All of those will determine kind of how you approach it next time. So maybe you have to not use script tags. Maybe you have to use a JavaScript URL slug instead. Maybe you can't use alert 1, you have to use input. Maybe you have to use a URL, right? You have to load a script from a source. All of that is going to be dependent on the type of form you're looking at. And when we go and do the live demo in a few weeks, and I'm going to talk about actually bug hunting, we're going to see this in practice and see how you would go through these steps. So what is the impact of cross-site scripting? There's kind of 3 key impacts. First is stealing cookies. So it's not necessarily the true impact of XSS anymore because very few cookies are HTTP only and kind of won't necessarily work. The other one is password autofill. So if a victim has a password manager which autofills a password, an XSS payload can actually capture that data as like the password manager is typing it in. However, the big impact is what's called CSRF. So that's client-side request forgery. That's something we'll be seeing kind of later on when we start to look at other types of vulnerabilities. But it's essentially this idea that you can perform actions as the user by sending the correct data to another endpoint in the web app. So you can imagine your XSS payload wouldn't say alert 1, it would instead say, hey, can you change this password for this account to just be the word password? We're going to cover that again in the practical live demonstration when I do this all live for you. So let's have a quick look about cross-site scripting in action, and specifically when we know something's not vulnerable. So give me a moment and I will get set up here. Okay, so we are back. And as you can see, I've got a Web Security Academy one up. I've got Burp running in the background, and I'm using Foxy Proxy to actually connect to Burp. If you're not sure how to get Burp set up, you can see my earlier video on how to actually get a hacking setup together. But the first thing you do whenever you're approaching any target, doesn't matter if it's a CTF, if it's a regular website, you always look at what you can do as a user and try and understand how it's supposed to work. So you can see it's a blog, we have posts, we can view a post, and we can have comments. We also want to see how all of this stuff works. So we can just put in some garbage and see, what are the requirements for a comment, for example. And we can see here, okay, it needs an email. And if we try and post a comment, and in this case, it needs to match the requested format. So this probably does need to be a URL. I'm going to press post comment, and I'm going to go back to the blog and scroll down, and I can see, okay, I've got a comment that now appears. That means that this is it's being stored in the database, right? There's nothing in the URL that's changed. It's all, if I just click again, it's all just loading up from the database. Great. So we know it's going to be a stored something. Now this is where we start to think about XSS. So there's lots of different ways to write XSS based on the context in which it's in. And I'll show you how we see that. So I'm going to go here, I'm going to right click, and I'm going to inspect element. Yeah. And see where my comment is appearing. How is my comment appearing? And how is the values that I typed in then being put together to make this website? So here we can see that the URL has ended up in an href. The name has ended up over here, and the value has ended up in a paragraph tag. So often you'll see XSS payloads start this, and that's because it's saying, hey, can you close the previous tag? But we don't need to in this case because none of these inputs apart from the href need closing, right? So if we look at this, we can see if we were to just inject here, for example, we would have http/whatever, then we'd close it, then we'd input our XSS. But if we're trying to inject into the actual comment here, we don't need to. So we don't need that. Because we're working just in HTML, we can start by doing a script alert 1, and then close the script tag like so. So it's going to be the same for the author here. Again, this is our name, but it's not being stored in something. So we can just copy that for the name. We know that the email has to follow the format of an email. And we know that the website has to follow the format of a website. So, okay, the two injectable fields we know must be the comment and we know must be the name. So we're going to press post comment. And then we're going to go back to blog. And you can see the XSS payload has appeared. But why has it appeared? Well, again, we're going to get up our inspect element here and take a look. So we can see that the XSS has fired in this paragraph tag because we can't see anything. Because you can see here, you see how this has gone grey in here? This is being read as JavaScript. That's saying, hey, this is JavaScript code, I want you to run this. That's why we can't see anything. But importantly, it does appear here. We can see script alert 1 script. Now, whenever you see that, that's when you know something is not injectable. Because if we actually have a look at our HTTP history here, oh, this one, and we scroll down, here is the actual result of this. Now, this is automatically encoding using HTML encoding. So while it's not the literal character of like a less than or greater than, it's this LT for less than symbol. So that turns into that symbol in HTML encoding, but it's not being read down here as HTML itself. So whenever you see this, this is not injectable in the same way. So this is where you have to start being creative. And this is actually where the difficulty of cross-site scripting really kind of comes in. Because you've got to figure out, okay, I can't do a less than or a greater than. It just won't work. What can I do instead? What other payloads can I try? So you might say, okay, maybe I can mess with the URL. Maybe you go in here and you try and put in something, whatever, as an email. And maybe you try, okay, so what if I was to put in a website and then I just close the tag? Can I then go into HTML like this? And then you'll post it, you'll go back, and then you'll see what's happened again. You have this kind of format of, okay, try this, does it work? No. Okay, try this, does it work? No. And here we can see that if we have a look at the request again, or the response, we can see that once again, this is being computed as a quote and then a greater than. It's being encoded as the literal key value. It's not being encoded as the special characters. We know that's not vulnerable. And this is, I think, something that gets missed a lot whenever we talk about bug bounty hunting, how to know when something's not vulnerable. And this is the hard part, right? People who are very good at XSS and can find XSS really reliable are very good at doing this. They know a lot of JavaScript contexts. They've seen a lot of WAFs and how they filter and can recognize different filters. They are people who have experimented with a lot of CTFs in order to kind of understand everything. But that is the kind of very basics of putting together an XSS payload. We'll go back to the slides and then finish up. So thank you very much everyone for watching this video on cross-site scripting. I know this was kind of a short tour and it's really just supposed to introduce you. And later videos we're going to go deeper. We're going to have a proper look at all these different cross-site scripting payloads and how they all work, and hopefully give you deeper knowledge than just put script alert 1 in every single field you see. So thank you very much everyone. Thank you for BugCrowd for sponsoring this whole series, and I will see you in the next video. Bye everyone.